Alright, so here's the lecture for Chapter 1 to Chapter 3 for Algebra 2 Trait Honors. So pretty much that Chapter 1 to 3, they all consider the refresh of Algebra 1, but there are some of the Algebra 2 contents, like some of the stuff right here, transformation, so we'll take a look at that. So for the template, so what I'm going to be going over here, it's the even number problem. So we're going to divide it into two parts, so the first half and the second half. So for the absolute value, so we do have this transformational form. It's always written as y equals a times absolute value of x minus h plus k. So for those you might be wondering what that means. So a, it just consider a scale factor. A scale factor, so that's showing, well, if a is greater than 1, so that means it's considered a vertical stretch for the curve. But the thing is that if a is less than 1, it's greater than 0, so that means it's considered horizontal stretch. Okay? And then h comma k, this one is just considered the vertex. So vertex, what that means is either considered the highest point or the lowest point. Okay? Another thing is that if a is less than 0, so that means the curve is going to be upside down. It's going to be showing that the reflection. So if there's a negative here, so we'll take a look at that. Like this one right here, we do have y equals negative 2 times absolute value of negative 3x minus 11 over 4 minus 7 over 4. So you might be wondering, this structure here, it's quite similar to the transformational form. But the first thing that you want to do, you always want to take out the greatest common factor if that's involved. So we got negative 2, absolute value of negative 3. So for negative 3, we can just take that out first. And now we do have x plus. Since you took out negative 3, so this one we change the sign because negative times negative turns out to be positive. And it's going to be written as 11 over 12 because that we took out 3 already. And then absolute value. Don't forget about that negative 7 over 4. And all the number here, they're not considered the ninth number, so it's a little bit difficult. So once we plot the points. So now, since we do know that absolute value of negative 3, it's 3. So we took out absolute value of negative 3. So this one turns out to be y equals negative 2 times absolute value of 3, so it's negative 6. And then its absolute value of x plus 11 over 12. And then minus 7 over 4. And compare and contrast, you guys can tell me about the value of a, h, and k. So the value of a, it's negative 6. And then the value of h, it's negative 11 over 12, which is getting close to negative 1. And then k, which is negative 7 over 4. So this one is pretty close to negative 1, so let's put it this way. And negative 7 over 4, that's about negative, well, it's negative 1 and 3/4. It's very close to negative 2. Okay, so let's just use some kind of approximation. So we do know that the vertex, so the vertex is negative, negative, so that's going to be in quadrant 3. So negative, negative. So it's going to be right over here. So negative 1, negative 2. So that's somewhere around here. Again, it's very close. So negative 11 over 12. And then negative 1 and 3/4. So it's about right here. Okay, so now the next thing that you might be wondering, can we find out some other points? The way that you can get some point, you can set up the xy table. And also the shortcut for doing that, you can use a. So a, for the absolute value function, is considered the slope. So once you deal with that, negative 6. So you can always use that as a slope. Now the thing is that since this one is considered positive and negative for the absolute value, so that means the slope could be either plus minus 6. So let's count it. So this one is going to be considered down 6. Okay, so down 6 units. And then 1 to the left. Okay, so down 6. Okay, let's count it. 1, 2, 3, 4, 5, 6. All the way down here. So this one is a little bit out of space. Well, which is fine. So we can just set up some other... Okay, so we need to set up some other scale. So -7, -8. So count it one more time. So down 1, down 2, down 3, down 4, down 5, down 6. And then it's 1 unit to the left. And then the other one from the same positions, you can go down by 6, but it's going to be 1 unit to the right. So eventually, once you connect them, so the graph is going to be like a V shape. Or you can say that the absolute value functions, the graph is consists with 2 rays. So one is going this way, the other one is going that way. Alright? Another thing that I can define is about the domain and the range. So you can say that, excuse me, the domain will be considered anything which is less than -7/4. That's for the range, excuse me. For the domain, then that will be all real number, because that pretty much you can use all the x value. So for the domain, you can say that it's all x is the element of all real number. Another way you can express the domain, it's the interval notation. So it's from -infinity to +infinity. And then the range, it's from -infinity all the way to -7/4. With the bracket, well, -7/4 with the bracket, that means -7/4, it's the highest position of the y value. So that's why we need to put in the include a sign. So that would be the bracket. Open sign, that means the number is not included. Because -infinity, we don't know how far it goes. It could be -1,000, -10,000, -1,000,000, so on and so forth. Okay? And now for number 4. Identify the min-max value. Again, min, which is the lowest point. Max is the highest point. Intercept, so that means we can find the xy intercept. The one on the x-axis, the one on the y-axis. So this one is saying that intercept on the axis parallel to the axis of symmetry, or the intercept on the axis perpendicular to the axis of symmetry. So which means that we need to find the xy intercept. So we do have 2 different types of parabola. One is just the normal one, something that you learned from Algebra 1. So the structure is always written as ax squared plus bx plus c. So this one is called the standard form. So normally the parabola would be either facing upward like this, or it could be facing downward like this. But if the structure is written as x equals ay squared plus by plus c, then this one would be considered the sideways parabola. So which means that the parabola could be either facing to the right or is facing to the left. Okay, so now let's take a look at that number 4 right here. So we do have a standard form for the parabola. So first thing that you can always do, you can always find the x-intercept. So in order to get the x-intercept, you can always set y equals 0. So x equals 6 times 0 quantity square plus 12 times 0 plus 11. So that means 11 would be considered the x-intercept. Another thing that I can find out is the y-intercept. Okay, so the way to find the y-intercept, you can set that x equals 0. And then you can solve for y. But the thing is that in order to solve for y here, then that would be a little bit complicated because you need to factor it. And it looks like this one, it's very difficult to factor because that it's considered even number with the prime number. Okay? So what we can do next. So we can just put it into, we can convert that to the factor form. So once you convert that to the factor form, so what we can do, we can find out the value of h and k. So another form I would like to introduce here, it's called the vertex form. So the vertex form for the regular parabola, the up and down parabola, then that would be considered y equals a. Again, the a is the same as the value of a right here for the standard form, times the quantity of x minus h square plus k. And then for the vertex form of the sideways parabola, quite similar. So it's x. So that equals a times y minus k, quantity square, and then plus h. Again, h comma k, it's just the vertex. So for both of them, h comma k, it's just the vertex. So what we can do here, we can complete the square for the quadratic equation. Okay, so let me get some space here. So I need to erase all this. So we found the x-intercept already, but now we just need to complete the square for the equation. So once we complete the square, we can factor it, so we can just come up with the exact same form as the vertex form. Okay, so what we need to do, so let's just subtract 11 on both sides here. Subtract 11. So we do have 6y squared plus 12y. And now what we can do next, we can take out the greatest common factor, the number, so 6. What about the variable? Variable, we just want to leave it because we want to complete the square for the rest of the quadratic equation. So y squared plus 2y. And now let's just set up the blank. So plus a blank. And then outside the parenthesis here, so we need to set up another blank. Plus another blank. Because we want to figure out the number to complete the square. And I'm sure a lot of you guys already getting familiar with the way to complete the square in Algebra 1. So the way to complete the square is about b over 2 quantity square. So back to the structure, the value of b, which is the second term here, so then that'll be 2 over 2 quantity square. So we got 2 over 2 to the power of 2, then that'll be considered 1. So that means we're adding 1 here. And now you might be wondering, what about the number outside? Did we add -1? Now got to be careful with this. The number you're actually adding here, it's not just 1. It's the product of 6 and 1. Okay, so because we took out 6 already. So what we need to do, in order to balance the equation, we need to subtract 6 outside the parenthesis here. So eventually this one is going to be considered x minus 11. So that equals 6 times the quantity of y plus 1 square, and then minus 6. And then let's get back this one to the vertex form. So we do have x equals 6 times the quantity of y plus 1 square. And then -6 plus 11, then that would be considered 17. Well, let's see. No, not -17. It's plus 5. Excuse me. Because you want to add 11. So eventually we come up with the vertex form. And then for the vertex form, guess what we can do? We can find the vertex, and then we can plot the point, and then sketch the graph. Okay, so now all those work here. So now I can set up the xy plane. So again, 11, 0, so then that would be considered the x-intercept. So once we get a vertex, we can also get a line of symmetry. So the next step, I'm going to show you the way that I plot the point and sketch the graph. Okay, so try to get rid of all this element. Okay, here we go. So we need the x-axis and the y-axis. So what we found here, so for h, which is considered 5, and then k, which is, well, this one got to be careful. So the form is considered x equals a times the quantity of y minus k square plus h. So for h is 5, and then k would be negative 1, because negative times negative, then that would be positive. And then for the value of a, which is what, 6. So plot the point. So we got 5 comma negative 1. So 1, 2, 3, 4, 5. Negative 1 down here. And you might be wondering which direction the parabola is facing to. So since the value of a is positive, so that means the parabola is facing to the right. Another thing we notice, the x-intercept. So what we found earlier, the x-intercept is 11, 0. So I need to extend the x-axis. So try to extend it all the way through. So we got 5, 6, 7, 8, 9, 10, 11. So 11, 0. And now, another thing we notice through the vertex right here, we do have a line of symmetry. So there's a dotted line going through here. And the line of symmetry, it shows the line of reflection. So since we do have 1 point here, so that means the other point should be 1 unit down. It's the same distance from the line of symmetry. And then basically we can just connect them. So it's a sine wave parabola. So it's going that way, to the right. So we can always check the word down the bottom of the page. So this one is for number 4. Well, this one, it doesn't even require to sketch the graph, but you want to find out exactly. So the mean value. This one is showing that the minimum value is 5, so that means, wait a minute. X-intercept, that's what we got. Y-intercept, none. What that means, it's the X value, the minimum. So that's correct. Okay, so the point here, we do have 5, negative 1. And then the x-intercept, 11, 0. Yeah, so this one, just identifying the, once you come up with the vertex, you can find out the max and the min. And then the x-intercept. Since we do know that it's facing to the right-hand side, so that means it's not going to intersect the number, the mark on the y-axis. So there's no y-intercept. So for the next one, it's all about the graphing. So do not worry about the focus. Do not worry about the directrix yet. So once we get into the conic section, we'll talk about those elements and the direction of opening, whether that's facing up, facing down, or to the left or to the right. The min max value, okay? So now, first thing that you want to do, you want to compare and contrast. So this one, it's just in the vertex form. So we just need to identify the value of A, H, and K. So A is 3, and then H is 1, and then K is negative 6. So it's 1, negative 6. So that's down here. Again, the point that's going through, so this one is also showing the line of symmetry. So since we do know that it's a vertical parabola, so that means this one, it's considered a line of symmetry on the axis, on the x value. Another thing that we can find out, it's about the y-intercept. So in order to get the y-intercept, so we want to set x equals 0. So set x equals 0. And then you want to set the table. So plug in 0, we do have 0 minus 1. So 0 minus 1, quantity squared, then that'd be 1. 1 times 3, then that would be considered 3. 3 minus 6, then that'd be negative 3. So 0, negative 3. And then on the other side right here, that's the equidistance. So that means it's the exact same distance. So 1 unit to the right, and then connect the dots. So that would be the parabola. And so the max right here, well, there's no max, but there's a min. So the min, then that would be considered 1 comma negative 6. And we do know that the parabola is facing up to the top. Okay, so it's facing upward. Another structure for the quadratic function is considered the x-intercept form. So the x-intercept form is given as a equals a times the quantity of x minus p, and then x minus q. And where that p and q, those are the x-intercept. So for the x-intercept, if we try to set that y equals 0, so we do have x equals negative 5, and then x equals negative 1. So negative 5 and negative 1. So the way to find out the vertex of the x value is by finding the midpoint of the x-intercept. So the midpoint, it's always consider x1 plus x2 over 2. So negative 5 plus negative 1 over 2, then that will be considered negative 6 over 2, which is negative 3. So negative 3 here, so you get the midpoint. But the thing is that we need to find out the y value for the midpoint. So whatever the x value that you have for the vertex, you want to plug in that number back to the original equation to find the y value. So y equals negative, well, a, it's negative 1/2. So negative 3 plus 5. And then negative 3 plus 1. So negative 1/2 times 2 times negative 2. So cross cancel, so we do have negative 1 times negative 2, which is 4. So for the y value, it's 4. So the vertex is negative 3, comma, 4. So negative 3 up 4 right here. So that means the parabola is going to be upside down. It is, because the value of a, it's negative. So once you get those points, all you need to do, just connect the dots. And that's the parabola. Another thing is that you want to find a y-intercept. So in order to find a y-intercept, you want to set x equals 0. So plug in 0, so 0 plus 5, that's 5, times 0 plus 1, that's 1. 5 times 1, that's 5, times negative 1/2, negative 2.5. So this one's supposed to be going through negative 2.5, so this one should be a little bit more to the right. Okay, let me fix that. So eventually it's going to be like that. Okay, so now let's see what else that we have for this. Okay, so another one, the vertex form. Identifying the vertex, the focus, the axis of symmetry. Again, don't worry about the focus. Do not worry about the directrix. So we just want to find the vertex, the mean max value. So this one is quite similar to the one I showed you earlier. The one that you need to complete the square. Again, if you see that it's x squared for the parabola, so that means it's like a vertical parabola. If that's y squared, that means it's a horizontal parabola. So the next type of problem I would like to show you here would be number 12, absolute value. We actually talked about this one for the Algebra 1 study packet, if you guys do remember. But this one looks like we're dealing with the special case. So anytime that you see the absolute value quantity, so that if that equals a negative number, so that means there's no solutions for the entire equation. Because absolute value, it makes everything positive. It cannot be a negative number. So that means there's no solution. So like this one here, if you try to multiply by 8, both sides, so we do have absolute value of 6x plus 1 equals negative 8. So that means there's no solution. So anytime that you find out the negative number and the absolute value quantity is being isolated, so that means there's no solution at all. And now what about the absolute value inequality? Again, absolute value inequality, if you see any absolute value inequality, it's less than or less than equal to any negative number. So that means there's no solution for the entire inequality. If you see the absolute value inequality, it's greater than or equal to or just greater than 0 or any negative number. So that means the solution is always considered all real solution or all real numbers. That means from negative infinity to infinity. So now let's do one problem here, 14. So before we separate it, so we need to get rid of the negative 6, positive 6 right here. So let me just rewrite it. So first thing that you want to do, S6. So we have 6 times absolute value of 9 minus 3b. It's greater than or equal to 126. And then you divide it by 6. So we do have absolute value of 9 minus 3b. It's greater than or equal to 21. And now, from here, we can just split it. Positive, negative. So for the positive, we just want to keep the original inequality without the absolute value. And then for the negative, again, the left-hand side is just the same. But for the inequality, you want to flip the sign over. So it turns out to be less than or equal to. And then the number, the constant, so it turns out to be its opposite, negative 21. And now you want to solve for b. So negative 3b, it's greater than or equal to 30. Well, let's see. Minus 9, then that would be negative 12. Positive 12, excuse me. And now from here, so you want to divide it by negative 3. So that means b, it's less than or equal to negative 4. And then over here, subtract 9 both sides. So we do have negative 3b, it's less than or equal to negative 30. And then b, it's greater than or equal to 10. So negative 4 with less than equal to, so that means a closed circle. And this one is going to the left, because that's less than. And then at 10 here, also is a closed circle, but it's going to the right. As what I mentioned before, if you see anything that's considered greater than or equal to for the absolute value, it's always considered a separation on the graph. So that means for the solution, they're not going to be intersecting. But the thing is that if you see anything that's considered less than or equal to, that means eventually they're going to intersect. Eventually they're going to meet. Okay, so for the absolute value inequality, so got to be careful with the special cases. And now for number 16. So 16, you want to solve for the equation by completing a square. So this one is quite similar to the one I showed you before. So before you do that, before you complete the square, you want to bring everything together to one side. So 15b squared minus 3b squared, we do have 12b squared. And then negative 3b, so take that element from the right-hand side to the left-hand side. We do have plus 3b. And then 18 plus 12, then we do have 30. And now we set that equal to 0. So since we do know that this one, we can take out the greatest common factor. So before you take out the greatest common factor, so let's just isolate the constant. So the constant, we just want to put it on the right-hand side. So we got 12b squared plus 3b, and that equals negative 30. Another thing we can do here, we can divide everything by 3. Or we can take out 3, it's up to you. So, but the thing is that since they're all divisible by 3, so let's divide it by 3. So we got 4b squared plus b, and then that equals negative 10. So now, what we need to do next, we want to take out 4. 4, that's the greatest common factor, so we got 4 quantity, b squared plus b over 4, or 1 4b, and then plus blank. So that equals negative 10 plus blank. So now, in order to complete the square for this, so we need to put it this way. So b over 2, quantity square. So negative 1 4 divided by 2, quantity square. So it's negative 1/8, quantity square. So we got 1 over 64. Again, it's not a nice number, so but the things that we can always distribute and then simplify it. So now let's find out the number we're actually adding here. So it looks like we're just adding 1 over 64. But the number we're adding, again, since we took out the greatest common factor, so we need to multiply this two number, 4 and 1 over 64. So we got 1 over 16. So the number we're actually adding here, it's 1 over 16. So that means we need to add 1 over 16 on the right hand side. Okay, so since I'm running out of space, so let me put it right here. So now we do have 4 times the quantity. So that means the rest of this is factorable. So it's b plus 1 over 8 quantity square. So that equals negative 10 plus 1 over 16. So that means it's considered negative 9 and 15 over 16. And also you can convert that to an improper fraction if you want to. Okay, so it's easier to just leave that with the mixed number, but the thing is that since you need to solve it all the way through, it's better for you to convert that to the improper fractions. So for this one here, we do have negative 9 times 16 plus 15. Well, it's actually 9 times 16 plus 15, because that's a negative number. So what we got, it's, let's see, 9 times 16 plus 15. Can I do it mentally? Just show the work. So 54, 1 times 9 plus 5, then that'll be 144 plus 15. So you do have 159. So negative 159 over 16. And now you want to solve for this. So by the time that you solve for this, okay, excuse me for a second. So in order to solve for this, we take the square root. But before you take the square root, don't you want to divide it by 4 first? So divided by 4 and multiplied by 1/4 both sides. So we do have negative 159 over 64. So we do have b plus 1/8 quantity square. And now for the rest of this, guess what we can do with the rest of this? So now we want to take the square root. So take the square root both sides. So we do have b plus 1/8. So that equals, well, it's a negative radicand, so that means it's going to be imaginary number. So that means we're dealing with I. So anytime they see like I, so that means it's square root of negative 1. So this one is considered root 159 over 8. But the thing is that's plus minus because that's a quadratic equation. So plus minus root 159 over 8 I. And now this one you cannot really combine the imaginary number with the real number. So what you can do, you can just simply just rewrite that. Plus minus root 159 over 8 I, it's outside the radical, and then minus 1/8. And that would be the final solutions. The final solution set. Again, this one involved with positive and negative. So now let's check this one. So this one, what number is that? 16. It's very complicated. Yep, that's exactly what we found. You can split it apart. You can just put it this way. Doesn't matter. So splitting apart, just like what the solution is showing. Or you can just put it like the way I did it. So that consists with the real number, the imaginary number. So the whole thing is called a complex number. Okay, so now the next one I'm going to show you, it's factoring. So I'm sure you guys are pretty familiar with the way to factor. Again, so just bring everything together to one side, and then you can either use the smiley face method, the cross method, either way. So we can set up the factor form. So now take a look at that, 18. So this time we are dealing with the big number. So how do we factor it? So first thing that you want to do, again, so try to bring everything together to one side, and then just rewrite it with the greatest power to the least. So the descending order. So 54b squared plus 2b squared, then that would be considered 56b squared. And then minus 456b. And then 65 minus 1, then that would be considered 64, plus 64. And now from here, so let's think about the way to factor this. And as you may notice, so we do have even number, even number, even number. So that means they're all divisible by 2. Well, but 2, is that the greatest common factor or something else? Well, let's find out. And it looks like this one, they're all divisible by 8. So a times the quantity of 7b squared minus 57b, and then plus 8. So that equals 0. Okay, let me check one thing real quick. And now for the rest of the trinomial, you can factor it. So factor it using the smiley face. So we do have 7b, 1b. And then over here, we can use negative 1, negative 8. So checking the inner product, so negative 1b, outer product, negative 56b. So combine them, so negative 57b. So for the factor form, it's written as, well, don't forget about 8, the greatest common factor. So this one, I'll put it right here. So 8 times the quantity of 7b minus 1. Again, left-hand side of the factor tree. You want to put those elements together. And then times the elements on the right-hand side of the factor tree. So b minus 8. So set that equal to 0. So we got b equals 8. And then b equals 1 over 7. Again, it's always two solution because that's a quadratic. The highest power, the number of degree, it tells you that the number of solution you need to come up for the zeros or the x-intercept. Okay, so we'll do one more problem, then we'll stop. So that will be the first half of this lesson. Okay, so the last one for the first half of the lesson. So we do have number 20. So this one, we want to use the quadratic formula. I'm sure you guys are pretty familiar with the quadratic formula. So quadratic formula is written as x equals negative b plus minus square root of b squared minus 4ac all over 2a. So again, before you do that, you want to convert that to the standard form. So 3v squared negative 7v plus av. Then that means we do have 1v. And then negative 3 plus 8, so we do have plus 5 equals 0. And then identifying the value of a, 3, b, which is 1, and then c is 5. And then all you need to do, just plugging that to the formula. So negative b, negative 1, plus minus b squared, so 1 squared. Minus 4ac, minus 4 times 3 times 5. And then it's all over 2a, so 2 times 3. Evaluate it using PEMDAS or GAMDAS. So we got negative 1 plus minus. So 1 minus, well, 4 times 3 times 5, then that'll be 60. Wait, no. It's actually 4 times 3 is 12. 12 times, yeah, that's right. So 12 times 5, which is 60. So 1 minus 60, then that'll be negative 59. And then it's all over 6. So that equals negative 1 plus minus 59. That's a prime number. Nothing we can do about it. So we can just take out that I. So negative 1 plus minus root 59i, and then it's all over 6. Again, two solutions set. Positive, negative. Alright, so any other question that you have, make sure that you join the office hour or the after school tutoring. So, and always, you're more than welcome to watch the video. The one you can always fast forward, you can always rewind to the one that you're having difficulty with. Alright, so you guys take care. So I'll do another video for the second half later today. Thank you for watching it. Bye bye.